So we're letting U1 and U2 be i.i.d. uniform. And there's an example in chapter 8, which we haven't done, but we'll be coming to in 2 chapters, that has a triangular distribution, f of t, and depending on where we are in the support, we'll have different PDFs. And they show that the method shown there leads to difficult integrals, so we're going to use the MGF instead to show that this has a triangular distribution. So starting by finding what the MGF of U1 plus U2 is, so that's a random variable of t. By definition, take 1 plus U2, whoopsie, like that, using the laws of exponents, and that the fact that this U1, U2 random variables are independent, we can write out, can separate out this expectation as ET U1, ET U expectation over ET U2. All right, and these will be as they are have the same distribution and all, they will be basically just taking it squared, any 1 or 2. Okay, and so let's calculate what this expectation is, and then just basically square it to get this expression here. So the piece inside the expectation, ETU1, is now, it has support 0 to 1, U, PDF1 over U. This gives us, now evaluating it, E2 half 0 to 1, and right, so I was a little fast here. I see that I didn't use Lotus. We should be using Lotus at this step here. So that, let me revert back. Just erase this. This should be e to the t u1 using Lotus. And this is now e to the t u1 divided by t. And that ends up being, you can evaluate that, that's, and let's see, that ends up being 1t, and this should be e to the t, so this is going towards 1, minus e to the t to the t, this goes to the t minus 1 t, right? And though, so inserting it back, we get now e to the t minus 1 t, like that, squared. Okay, that's the MGF of U1 plus U2. Now we're going to find the MGF of any random variable that follows a triangle distribution and check whether this will be equal, and then we conclude that indeed U1 plus U2 is triangular. Okay, so let's set x to be having a triangular distribution. So let's let x be a triangle. Just call it like that, and it will have then, by definition, its MGF will be Tx like this, and then it has an integral. It's continuous from, and imagine, well, we see that this goes from 0 to 2, but there are actually two integrals with two PDFs depending on where we are. So we can start by just writing 0 to 2 Tx, and now this is not using Lotus, we're just using the true distribution of well, this should be x here, and there's a term here is t, but that doesn't matter. Dx. Now, separating out these integrals, we get e to the t x, and f of x is, so the PDF is only t, and this interval 0 to 1, and then and the remainder, so from 1 to 2, it is 2 minus x dx. Okay, so keep on evaluating this. So this part here is the simplest one, so let's just evaluate it. That is e t x divided by t, evaluated from 0 to 1. Okay, and that is, in fact, let's just do this here. So this equality refers to that expression there, and this is e to the t e t minus e to the 0, so that's just 1. All right, that's okay. That's sort of moving towards what we have this form here again appearing, but we have this other part here that looks a little complicated, but let's keep on doing it. So this, I'm going to copy this piece, just say this here is obviously here. Okay, the integral 1 to 2, let's multiply out e to the tx, and we have now 2, this is the 2 from there, dx plus 1 to 2, but there's a minus sign here, so we're going to write minus x e t x dx. All right, and so this part here is exactly what we had up there, but we have a 2, so let's just evaluate it. This is 2 to the, it's a little thick, this pen here, e to the t e t x 1 to 2, and then we have this other thing here. We're just going to handle it in a minute. And so this is now t2, and the limit is now going to 2 like that. And this part is going e to the t1. Okay. So, and the remainder, this part is an integration by part maneuver, because we have the x there and the x there. So let's do that. So I'm going to move it further down here, and the integration by part formula, I tend to not really memorize it, just thinking through what it actually means and where it comes from is a little easier for me to memorize. So let's do that now. So where does it come from? Well, let's first just write any function g of x, h of x, and we take the derivative of it with respect to x. That will just be equal to the derivative of x, h of x, plus g of x, like that. Now, taking the integral, became a little messy. Let's do integral d of x integral. This is now just, we're not doing anything new, just taking what we did to the left hand side and do it to the right hand side. And then here we end up having, let's move this expression to the other side. And so we end up having, I think it's easier if we copy this, duplicate this. I'm going to make some space here. I'm going to move this here, moving this part. Then we'll have a minus sign. It's a plus sign there. This is it. And this is where the integration by part formula comes from. And then what we have now is that this part to the left is just evaluating g of x, h of x over the support of x. And now we end up just having the same thing here. And so what does this mean actually? Well, all right, sorry for that a little bit of a messiness, but now we can see that, okay, so we can have the harder expression. If we can we put the harder expression on the right hand side and the easier expression to the left hand side, especially after taking the derivative of whatever is easy, we should be left with this whole thing easier or solvable compared to the right hand side. And this we just evaluate as it is. And looking at what we have, let's try to figure out what should be what. Where if we take the derivative of x, that's just 1. So that looks pretty good if we can put x to be g of x, and then e to the x is just h of x. And so now having a plus, integrating, I'm just saying now our stuff here, so this equality now just follows from what we have here in this expression. Now this should just mapping it now, this should be that the derivative of g, so of x is just what we said, x, and that's just 1 times e to the t of x. We integrate like that, minus, and in our case we are evaluating from 1 to 2 of x e to the t of x, okay? Because we're just basically plugging in g of x as x, h of x as et of x. And what we're left with here is g of x is x, h, the derivative of h is e to the t x, and don't forget the t, so we have a t here, so we will need to divide to make it exactly, to make this right hand side equal to exactly this side, we need to divide by t so that we move it to the left hand side. So let's just don't forget doing that. We'll be writing 1t in parentheses just like this, and then e x 1 2 e to the x dx like that, and proceed on this basis. Now all these things are now much easier. Oops. So this is 1 from 1 to 2, and let's evaluate this expression. Well, that expression becomes 2 to the e to the t. 2 minus 1 to the e to the t. 1. Okay, and now with this, evaluates to e to the t x 1, 2 divided by t, which is, there's a lot of e's now. E to the t, 2e t, 2 minus e to the t. And this is now, right, let me just calculate this here. And so that's e to the t, e2t minus e t, like that. Right? Just double checking. E to the t is that, yeah, looks good. So we write it down here. E to the 2t minus et. And so that is what this expression is here. So let's duplicate it like that. Okay, so now we have a few threads moving around. We have, if you look at our expression here, we have this being this expression, that expression being that plus that, and we just calculated what this is. So let's put it all together by going to copy, let's see, let's copy this piece here. Where are you? That's the copy. Move it down here. We're going to collect all the pieces. And we have this piece up here. Right, and then we have, so that was that piece. We have this piece here. duplicate. We have a minus sign here, right? We're going to have to bring that along. So here we have a plus, and then we have a minus, right? This minus is coming from this piece here, and this red expression is just this one here that we calculated as the following. So we can copy this one, move it up like that. All right, so now we are almost there, but we have a lot of mess to clean up, which is to put all these things together and see how they indeed evaluate to that simpler expression. So let me just make sure that we're not missing anything. So we have what we can do here is let me see, we have the e to the t, we have the t's, we have the 2 t's, the 1 t, the 2 t, the 1 t, the 2 t, the 1 t. All right, so let's try to collect all those that go together. They stay together, and then we'll see how that whole thing evaluates to that expression. So I'm just making sure that I'm not missing some of the t's. Right, so we have that. We have that there. Yeah, so right, just realized that we have forgotten this piece here, right? Because when we multiply this in, we get that. So let's see, did I that's squared here, right? We should be having a squared t there, and that comes from actually, right, so it should be like this, just to be entirely correct. Okay, let's see if I'm not missing anything from the blue part. Looks okay. Okay, so let's try this out. It might be okay, so 1 to the t, we have 1 to the t there. Et minus 1 plus 2 like that. Let me just, yeah, right. So I keep on tricking myself. It should be parentheses like this. 2t e to the 2t minus et. And then there's a minus here. That gives us, let's multiply it. Let's open that parentheses. So we get t, there's a 2 et2 minus et. When we open up this parentheses, this becomes a plus, right? Let's see. No, so we, yeah, should be still minus here. And well, just to be absolutely clear, maybe it's better to put it on separate terms. We want to separate out the 2 t's and the t's like this, and then, well, this becomes plus. This is a t squared e to the 2t, and now this is plus, but then minus e to the t squared. All right. Now let me just double check. So there's so many negatives and positives moving around here. So there's a minus, minus. So this when we take this, we get 2t. Right, this looks okay. There's a minus. That becomes plus. This is it. And then we have a minus this part. That becomes positive, and there's a minus times this. This is a positive, becomes all right. This looks good. Let me keep on just collecting. Before moving on, let's just write this as an ET, and then there's a minus T. Just again, just collecting the pieces wherever they should be collected, and right, minus T, okay. Now let's see, we have, this is the 2t, this is a 2t, this is a 2t, but this is squared as well. So this and this cancels, okay, this cancels, and this cancels, right? And we have that, and that becomes 2et t, and then we have just a minus 1t, and this we can write like e to the t, t2 minus t2. Let's see, this is, let me just write it out. Let me just remove this, sorry about that, and write it as minus e to the t e to the t. Just checking my notes whether this feels like there should be a t here. Let's right, there must be a t there because we have e to the t to right. So it's coming from this blue piece, so this should be e to the t right. Okay, so things are getting confusing. 2 divided by t. All right. Minus 2 divided by t. And yeah, we just collected this blue thing, so we're done with this blue thing here. And we have this here, and then we have plus t squared e to the 2t minus e to the t squared. Okay. We gradually and slowly getting there. What we can do now is that we can put together, put this whole expression under the same term. So we do it under t squared. So if we do 2t squared here, we'd have to do 2t, and then there is minus t, and then there is a minus 2t et. Okay. And then there is a plus t e2t, and then there's a minus t. No, those already have, my bad, going a little too fast. E that squared, that's just et, and this is just minus et. Okay, let's see, we're soon there. Can we cancel anything else? Well, we have this cancels, And then we are left with e to the t minus t, and this t there. Okay, so minus 2t. Okay, so I realized that I made a simple mistake here with the with adding and subtracting all these terms here, but basically let's put this whole thing into parentheses, and what we are getting is that we're getting the following terms, so that we're getting e to the t minus 1 t squared and plus 1, and we have t squared, not as I've written there, and then there's a plus 2e 2t is divided by t, the minus 2et like that, and then there's a minus e to the 2t. Oh, let's see, what did I do here? Yeah, exactly. This is correct. E to the t 2t minus 1 like this, and then there's a plus e t minus 1 t squared, and this whole thing, indeed, after subtracting and adding, basically just manipulating this whole thing, we get e to the t minus 1 squared t2, which is exactly what we were supposed to show up here. If we just browse up this piece here, so we conclude that u1 plus u2 is indeed having a triangular distribution. So in the second part of this is to show that the triangular distribution equals, as I said, u of u2. So here we just let x be triangular, distributed, triangular, and then we calculate its MGF. So by definition, it's the exponential e to the tx, which is, so it goes from 0 to 2 e to the tx over its own distribution. So we're not using lotus, t of x, and its own distribution is defined here using the variable t, but we can just easily call it x, and it has different PDFs depending on where we are in the support. So let's write that out. So from 0 to 1 we have e to the tx, and then the PDF is just x dx plus 1 to 2, and then the support is e to the x, its support is let's see, it's 2 minus x dx. And moving on to evaluate this, we see that here, because we have x here and e to the x, we have to use partial integration, and we have another term here that we will have to use partial integration for. So let me write this whole expression out as right. Let me just remove this, and we separate out this other sum. Oh, it's integral. I mean e to the x. Then there is a 2. So that's the 2 dx. And then there is a minus going from e to 2. That is e to the tx x dx. All right. So at this stage, we are calculating each and every integral. So we can just call this, integral 1, integral 2, integral 3. Now do them separately and then just add them and subtract them as we have done here. And so as we're asked to do here. So let me do this one over here. Here we use partial integration, and the usual way that I tend to memorize it is just to actually derive it again. So imagine a function g of x, h of x, that we take the derivative of with respect to x. That gives us g of x, h of x, plus g of x, just using the rules of derivatives. And then in the next step, if we now undo this, let me just copy this, undo this derivative, we take the integral over x, dx, integral here, dx, integral here, dx over x over x. And now we move this part to the left hand side, and we ending up with this harder integral on the right hand side. That's the principle. So I'm just going to copy this. Let's see, copy this, duplicate like that. And now, because we move this to the left hand side, we just take a minus, and that is now an equal sign, like that. Okay, we're almost done. And because we have taken the derivative and then the antiderivative, we end up just having to evaluate this over x, and the rest is whatever it remains. So this becomes now as simplified as possible. And now we ask, how does this map into our problem? So for this expression here, we see that if we take the derivative, if we put g of x being this expression here, when we take its derivative, it will just become 1. So this would become 1. That's not much easier. It means that we can leave h of x as this expression there. So it's e to the t x. Okay, and so now the right hand side is just going to, this is, this inequality just means our problem now, our problem, which goes 0 to 1. G of x, we just let that be x, and the derivative of h of x is e to the t of x, and then there's a t dx. And now we can write out e to the tx here from 0 to 1 dx, and g of x, h of x, that's just whatever to the x remains here from 0 to 1. All right, so that's using partial derivative, deriving it from the original type of style. Okay, and I think it's like the du dv type of thing doesn't resonate with me fully. I end up getting confused, so I like to just derive this from scratch. Okay, so now let's keep on doing this, evaluating the left hand side. So first of all, look at this t here. Let's just kick it to the other side, so we get this equality set up exactly as t x dx. Now we have this exactly. This right hand side is exactly what we want to calculate here, up here. Okay. Evaluate e to the evaluating this piece. So we have now that's 1 e to the t. That's 1 there, and then whatever negative we subtract off. Evaluated 0. That's 0. That's just how it is there. So we're done with that. And this evaluates to e to the t x divided by t. And that goes from 0 to 1. Okay. This whole left hand side is now the e to the t minus. Right, and let's just evaluate this expression first. And that is e1t e to the t minus 1. Correct? Let's see. Let's do it again. E to the t1, right, minus 1 exactly. Yeah, that looks good. So this whole thing is now to the t e t minus 1 parentheses, and then so just simplifying a little bit here, we get e to the t minus t squared e t minus 1. So that's what this right hand side expression equals to. So just double checking here so that I'm not missing anything. To the t, right? Yeah. So this looks good. There's if you like this to be simplified in terms of the t's, right. Right, so let's see, we can do e to the t minus e to the t2 minus, well, that's a plus, t2, and then this we can pull out. All right, so we can just multiply by t there. So we get now t2, we can t minus 1 plus 1 t2. Okay, so that's another way of just writing it. We move on and we do number 2 there. You know what? Let's do number 3 because it's basically equivalent, just that the sum, the integration is moving over a different area. So let's do 3 here, and here we then doing the same procedure, we end up with let's see if we can figure out, well, we're just actually can just copy this piece over here and then change the area of integration. Let's see here, copy, okay, right, so let me just put it like this, and then having this equals that, and we are doing over 1, 2 equal, and this should be 1, 2, should be 1, 2, 1, 2, 1, 2, right, and we move over t again as said, like this, and then we integrate here, so we have 2 e t, so that's a 2 minus 1 e t. Let's just move the 1, and then this equals to minus the same thing here, except for this being obviously easier. So we have 1 t e t x, integrating from 1 to 2. Now this is 1 divided by t, t2 minus e t, like this, right? And then we have this whole thing multiplied by 1 divided by t. So that gives us 2e to t minus e t divided by t. This whole thing becomes 2 squared t. Squared t. Okay. Now, doing the last piece here. Where are we? The last integral. I'm going to copy this whole thing. Copy. We're going to now evaluate this whole thing, and this piece here is the one that I haven't done, and that is basically, so that's 2 evaluated e t x e 1t 1 to 2, which is 2t e 2t minus et. Right. Now, putting all the pieces together, you know, we take 1, we take 2, we take 3. There's 1? Yeah, that's 1 here. Now, doing all these together, I mean, I'm going to just basically, I'm going to just basically let this whole thing, I'm just writing it out now in terms of whatever we have there. So that's e t t minus 1, t squared, and then we had plus 1 t2 plus 2e2t divided by t, and then there's a minus 2e2t divided by t, and then we have another minus e to the 2t. Just simplify the other terms here. I'm taking this directly from the calculations in my notes, plus et, and then instead of moving through and showing you all the full simplifications, but this is now just algebraic simplifications, and this yields in the end e to the t 1 minus square 2 to the t squared, which is exactly what we wanted to show up here.